Good morning. Okay, David, start talking. All right, let's see if we can get David talking. Okay, David. Good morning, this is the 20-minute mobile mentor. I'm trying to get David to speak. All right, let's still trying. Hang on with us. Technical difficulties, you know how that is. Good morning, David. David does not want to say anything, but welcome to Walter State this morning. That's what he says, and he hopes that you get something out of today's session that you can use in your own classroom. I apologize for him not wanting to talk this morning. I guess he's not had his cup of coffee. So we are in one of the labs. I was just talking to Donald, who I'll introduce in just a second, but he said this is the lab, this is the lab, this is the 3D studio, this is a tutoring lab, this is just an all-inclusive area. So I want to introduce you to Donald Choate today. He's going to be talking to us about 3D printing, and I'm so excited to be with you today. Donald, thanks for taking time to do this.
Well, thanks for coming in.
Okay, so good morning, and what have you got for us?
Oh, we've got a 3D printer here today.
Okay.
We're going to talk a little about the printer first, then we're going to move into some of the stuff we've designed for it. This is the Markforged Mark I carbon fiber 3D printer. It prints using carbon fiber filament. It'll print using fiberglass filament, Kevlar filament, and nylon. And we've got carbon fiber spool in the very back there that you can see. And right here is a spool of our fiberglass. We have printed with both of them. These give strength and rigidity to your parts. And then here's our main material. This is nylon. So all of the parts generally that we print here are made out of nylon. And you can see some examples on the bench over here.
Okay, so these are some of the things that you've made out of nylon.
Yep, these are just some of the things we've made. Some of these were automatically generated from the internet, the cubic chain. Some of them were designed by us. This is a iPhone case.
Yes, it is.
Little prints for media, little figures, Sharkman. And our newest venture is printing out chassis for robots.
Okay, so what are you going to do with this?
Well, this is an autonomous robot here, so when it's finished, he'll have sensors somewhere. Yeah, here they are. He'll be 100% autonomous, powered by an Arduino, and we'll have these little depth sensors on it. And he'll just kind of move around the room. He'll stop at a ledge if he sees one, and he'll back up and move somewhere else, like a Roomba. It's a little simple Roomba, and he'll just walk around till his batteries die out.
And you made that out of this material that I'm seeing right here in front of me, correct?
Yeah, we design it. We either use AutoCAD, SolidWorks. I like to sculpt very organic stuff. So sometimes we'll actually use Mesh Mixer or Blender to do certain things with. I've got Mesh Mixer open up over here.
Okay, you've got a question. Are you printing science models yet?
Absolutely. We've had students come in and request chemistry is really popular. We have molecular models we print out, orbital models. The strangest thing that I've ever been asked to print out was a set of human teeth for a pre-dental student, and yeah, we printed out human teeth for them.
Okay, someone's thought about printing objects for the A&P labs?
Mm-hmm. Oh, absolutely. That's 100% possible. We have a database built up on our software. The software that powers the printer is called Eiger, and we have all kinds of organs, vascular systems, bone models, skulls, anything you could want. A lot of our models actually come from the National Institute of Health. They have a 3D print exchange where you can grab all kinds of scientific models. Thingiverse is is a place where we get some of our models from. The Smithsonian. There's a few other places where we grab some of our anatomical models. And of course our 3D scanner, we scan some of our models as well.
Oh, that is just, I just can't even fathom the thought that this is happening right here on Walter State campus.
If you'd like to see inside the printer, I can show you that too.
Okay, and someone says, is there a cost for students to get a print?
There is absolutely no cost to you guys to print. We'll come in here, you ask for it, we'll print it. Educational stuff gets priority, but I'll pretty much print anything you want. But there is no cost to you whatsoever.
Wow, wow. Someone says 3D printing isn't real.
I mean, we're looking at it now.
Okay, someone said, okay, they say it's a hologram.
It's a hologram. Well, those aren't real, but this is real.
Okay, they say he says this is real, so tell us what's going on here.
Okay, so basically 3D printing in this form is nothing more than a really fancy hot glue gun. So,
sorry to interrupt you. Someone wants to know what kind of printer you're using.
This is the Markforged Mark 1.
Okay, once again.
The Markforged Mark 1.
Okay, there you go. There's your answer.
And this is actually an industrial quality printer that we received from Novacopy. But if you would imagine just a really fancy hot glue gun. So we have an extrusion motor that pushes material, whatever that material may be, through our tubes and into our print head that has a heated nozzle in it. You may be able to see that nozzle if we can kind of bend down here. I don't know if you can see it, but there's two nozzles here. The one in the back is for the nylon. The one in the front is for our fiber filaments. And all it does is it's a heated head. It heats up to about 273 degrees Celsius, and then the nylon just gets pushed through it. It melts, and then like a plotter just kind of plots it out.
So what are we going to be making right here, Donald?
We are printing out a Walter State keychain for you. You can see a finished product right over there. It's this one right here in the center. Oh, it's actually finished.
It's finished?
Yep. It's a little loud.
That's okay.
But that's the finished product there.
Oh my gosh. Look at this. Now, Donald, from start to finish, how long does that take?
This took, including... Well, I'm going to include the design time, but it took about 18 minutes to print out. But keep in mind, this is an industrial quality printer. This thing can print out motorcycle parts, small car parts, and our compatriots at TCAP Morristown have used it to produce those high quality parts, carbon fiber pieces for motorcycles and that sort of thing. We've been actually playing with it, and one of our professors in the science division who plays guitar requested carbon fiber picks. So I designed some carbon fiber guitar picks for it.
Oh my gosh. Okay, somebody just asked a question, and I'm so sorry. I was caught up in the moment, and I missed that question. If you want to repost it, if he's not answered it, please send it back through, and I promise I'll get it to him. I was caught up in the moment.
But going back, though, I just saw something I'd like to talk about.
Okay.
So students are available to come in and request parts. This is a part a student requested yesterday. He needed a handle for a hose. And so he found this online. It's freely available. It's under a Creative Commons license. It's not piracy. It's not plagiarism. So we grabbed it, we 3D printed it, and this student's going to come back in Wednesday to pick this part up and deliver to me something out of a motorcycle he wants me to replicate in carbon fiber. But I can 100% do that for him. We have a print area on this here that's about 12 by 6 by 11. So that's the maximum size we can print. If it's bigger than that, we'll have to slice it up and print it in chunks and then reattach it.
Okay, someone just asked the cost of the nylon.
The cost of the nylon to print a cubic centimeter is pennies. It's probably about a quarter. Their prices did go up. The carbon fiber costs us about $5 a cubic centimeter to print. The fiberglass costs us $3.25 to print. The Kevlar costs us about $4 to print.
So if you're not charging students or faculty, how is that happening?
This is paid for by the fees that are included with tuition.
Okay, someone's asking, how detailed of measurements do you need, and what's the minimum? I guess that's what he means.
There really is no minimum. I mean, the smaller your parts, the less accuracy you're going to get, because the printer can't print super, super small.
Okay.
We can actually tell the software to ignore those settings, but you're going to lose some of your dimensional accuracy. These little keychains are about the smallest you can print at an accurate size.
Can you make scissors, someone says?
I can make scissors, yeah.
You can make scissors, and someone says they're using this in medical school. They just put a post here that says they've been, I guess, using
Oh, absolutely. 3D printing, or TCAP would probably appreciate this more. It's additive manufacturing is a technical name for it. It's been around for well over 30 years. And you can print pretty much anything: concrete, cake batter, flesh.
Okay,
you can print living tissue.
Don't, if it's been around that long, why are we just now hearing about it?
Okay, so these printers are extremely expensive. If you were to have purchased this printer new, it would have been $9,000. So it's only been in the past 3 or 4 years that these printers have gotten cheap enough for people like me and you to buy one and stick it in our homes. You can get a very good 3D printer now for about $400. Now that's the price of a decent laser printer.
Someone says that they learned how to make a heart and lungs using the 3D printer, I guess, in medical school. Wow.
I would like that person, they're posting live now, right?
Yes, they are.
What did they print it out? Can I get that information from you? I'd like to know what material you used.
Okay, viewer, if you can please send in that information, I'll pass it on to Donald. What material they
Yeah,
used?
a lot of the medical quality printers, they don't use this sort of material. They'll use a resin. So it's a laser printer, and a laser beam will go over a pool of resin, and it will harden the resin, and then it will just slowly, like the Terminator, it will slowly rise up out of that pool, and there you've got your printed material.
Someone says Nashville has 3D printed sculptures. Ooh, that's a different take.
I've actually got in our database a full skeleton of a Tyrannosaurus Rex that I'd like to eventually print out. This is that guy you see here. Yeah, this is a shrunk down version. This is half of the original size. I'd like to eventually print that whole thing out and have it sitting in the main office there.
Wow.
But beyond the 3D printing, you know, I mean, how do we make the models? We can make them by hand in Blender or Mesh Mixer like I've got open here, or we could 3D scan. And we have a Sense 3D Systems 3D scanner here.
Okay, so someone says, sorry if asked before, how much would a good starter printer for home cost? I think you said $400?
$400 is a decent price. And at the end of the Periscope here, I'll give you guys my contact information. So if you'd like advice on 3D printers and 100% non-biased on this, I mean, this printer here has given us a whole lot of trouble, and I would not recommend this one until they improve upon it a little bit. But if you guys like some advice on some 3D printers or what would be a decent brand to go with, you can get in touch with me, and if I can't answer it, I'll definitely get in touch with a professional that we know who has many years of experience in reverse engineering and additive manufacturing.
Okay, so audience, stay tuned, because at the end of this Periscope broadcast, he'll give his contact information. So what's about to happen now, Donald?
Okay, so I'm going to 3D scan you.
Oh my gosh! Okay,
So
I'm going to flip the camera.
We're going to use our mobile 3D scanner. It's a Sense 3D System scanner, the same people that make the Cube 3D printer.
Okay.
Do just your head there.
All right, so he's going to start scanning me. I've never had this done before. All right, so I guess we'll have to finish. Oh, he's going now. So
so if you just back up just a little bit there, I'm going to have to walk around you. We'll probably
here?
grab. Yep.
Okay.
We'll probably grab your side. The iPad might be in the way there.
Is that better?
Yep. Okay, just stay completely still for me.
Oh no, he didn't just ask me to stay still, did he?
Okay, we're going to grab your.
And he's walking around me right now, and I'm trying to stay as still as I possibly can as he scans.
Okay.
Okay. So what just happened, Donald?
Okay, so this is a depth sensing camera, and it grabbed a decent model of you here. We couldn't get the iPad, so a little bit of your nose is missing, but yep, so we grabbed a color scan of you. And what we would do, if we didn't like this scan, we would go back in and perfect it, and then we would pull it into some 3D modeling software, and then we would fill in the gaps, we would smooth things out, and then we could print you a bust out.
Are you serious?
100% serious, and I've scanned students and printed them out before. And the reason that I'll print pretty much, the reason I'll print pretty much anything, and this is something you guys should take note of. If you are looking to purchase a 3D printer, some of your materials have shelf life. So the nylon, it's very hydrophilic, it loves water. And when it gets wet, it can really ruin your parts.
Okay, David White says we want one of those. I'm not sure what he wants, the printer or me. I don't know what he wants. I guess he'll tell us here in a minute. This is so. What is the tool? Is that a Surface?
This is a Surface Pro 4. Yep. Now they make this scanner. You can use this on any PC. They're all PC compatible, but they do make a scanner for iPads. And then if you have an Android tablet that has Intel RealSense cameras, you can even use those cameras to 3D scan things. I've even used an Xbox Kinect. You can grab the Kinect SDK and an adapter kit, put it on a tripod, and you can use it to scan people. There's multiple types of 3D scanning technology. This is just one of them.
Okay, so how much is the scan? How much is that handheld scanner? What are we talking about?
This was $399.
Okay.
These are really expensive, and you're going to get up into the $40,000 range for a professional one.
Wow.
Yeah. But like I said, any camera can 3D scan. It just depends on the software you're using and if that software will support it or not. Autodesk has a really neat Android app that I'd like to send to you, where you can use your camera phone to snap pictures of an object, and it will build a 3D model using those pictures. It's 123 Design is what the name of the app is.
Okay, here's a question, and I want you to repeat that in just a minute. What about a Mount Rushmore of our mobile learning fellows?
Why not? Let's just get them all together. We don't need them all together. We could just scan each one and stick them together.
OMG, great idea, David.
This file can be saved. We can upload it to the cloud. I don't know if you'd like that or not, but we can upload that to the cloud. We can share it out to the public.
I'm probably in the cloud somewhere. I want to go back to what you just said, a certain brand.
Yeah, so Autodesk, which are the some of the more popular CAD developers, they make AutoCAD, has an Android app called 123D or 123 Design, and it will allow you to snap pictures of an object, and it will build a 3D model from those pictures.
Okay, how much does that app cost?
It's a free app.
That is just amazing. So really, I know you get a higher quality with that you used with me.
Mm-hmm. And if we wanted to set up light boxes and put it on a trolley that we could then circle the floor, we get an even higher quality image. You know, I was holding it, so it get a little bit shaky, kind of having to move back and forth, dodge benches and chairs, but we could get really high quality scans. Even with this is a low end scanner for $3.99. 3D scanners are not something that's cheap right now, but we could get extremely high quality scans out of this guy too.
Wow.
If we set the room up properly.
That is just absolutely amazing. And then once you've scanned, that goes where? I mean, I know it's on the surface now, but where does it?
We could store it locally. It'll scan and store it as an STL. It's a lithography file. That's a lot of your popular editing apps like Blender, Mesh Mixer, those apps will support STLs. It's just a simple 3D modeling file.
Okay.
So we would use that STL. We would then upload it to an editor like a Mesh Mixer here if we wanted to, edit it to our heart's desire, and then we could export it out to our 3D printer software.
Okay, someone just said, can you add color?
Absolutely, and there are printers out there that print in color.
Okay, so this one is not a colored printer that we have, correct?
The color depends on the color of the filament. We have what's called, this is clear.
Okay.
And it doesn't really print out clear, it's more of a white. And then we have natural, which is this material right here, and it'll print out it won't be as translucent as this, it'll be more this shade, and then I've got black nylon. And they make glow in the dark filament too, so that's even cooler.
Someone says you should put a package together.
Oh, really? Good idea.
All right, so then this scan of me goes into your software.
Yep.
And then the software actually hooks up to the printer, and bing, bang, boom, how many minutes later will I appear?
It depends on how big you want it to be. If we wanted to print you out maybe a little 4-inch bust, probably 5 hours, 5-6 hours.
That's amazing.
Yep.
That is amazing.
We don't actually have any software connected to this printer. This printer, if you were to look in the back, it's not like a printer at home. It's networked. It's not. There's no USB that goes to it. This is a cloud printer. We could print to this printer from anywhere in the world.
Which is even a plus. Is even more of a plus.
Absolutely,
because you don't have to have anything hooked up.
The software actually runs through Google Chrome.
Really?
Yep. The software will run through Google Chrome, and we could print from anywhere in the world. If we're in China and we're at a manufacturing plant and they're showing us a prototype and they want us to see it and they share it with us, I could be standing there in that plant, open up the Chrome on my phone and send it to the printer back here in the States and have it by the time I get back.
Wow.
Yeah, this is a cloud-based printer. It's one of the few printers in the world that actually do that.
So most of them are hookup type.
Most of them are tethered. Yeah, they're tethered to your computer. Some of them work autonomously and some of them are cloud-based.
Okay. All right, and the app that you're talking about that goes on, sorry, somebody says the price of that printer.
The price of this printer, brand new, was $9,000. It's gone down now because this is the first generation. That company now has a second generation, the Mark II.
Okay.
And I don't know the price of it yet. We're still working with the first gen here.
Okay.
It'll be a while before we upgrade to the second gen if we do.
All right, so if I use my phone with the app, that goes up into the cloud.
Yep.
And then, because it's in the cloud, it just prints off that printer if I wanted to do that, correct?
Yep, so we would network the printer, and then we would just open up the app on your phone or your tablet, wherever, what have you, and pick the printer from a list if you're lucky enough to have more than one, and then send it to the printer, and you're good as rain.
Amazing.
Yep, set it up and ready to go.
Boy, talk about making a difference with students. That would be amazing for students to be able to have a printing capabilities really, I want to say from their own device, but you know what I'm trying to say is because they can use their device to capture something.
So I've actually opened the web portal for our printer up on the tablet. So let's grab a part and we'll take a look at it. Something that's, we're on Wi-Fi, so you have to excuse the speed. This is the spray nozzle the student wanted printed out.
Oh my
so this is what we would see. We could even load it with carbon fiber or fiberglass or nylon if we wanted to. This is a neat feature though, so we can actually control where we wanted to inlay this fiber. So this is the internal view. So what this is going to show us is basically like an X-ray of what this part would look like. So we could go from the internal view to the 2D view, and then we could go layer by layer.
Of everything that's making that part up is what you're doing, right?
Yep. So this is layer 95 out of 441, and then we could actually tell it to use fiber, and then we could choose the fiber that we wanted to fill it with. Right now, this is looks like it's carbon fiber, but we could change that over to whatever we wanted to.
Amazing.
And it would fill in with fiber, and then we would send it to the printer, and it would print nylon, and then it would print a core of carbon fiber, which would give the part excellent strength and rigidity.
That is just amazing.
This printer has a maximum resolution of 0.1 millimeters, so that means that's the layer size it prints.
Wow. Okay, guys, this 20 minutes sped by this morning. Lots to see and do with 3D printers. If you have more questions or you'd like some advice, I can tell you Donald can, if he doesn't know the answer, he can get you the answer. So what is your contact information, Donald?
Okay, you can find me on Facebook at Donald L. Choate. That's C-H-O-A-T-E, Donald L. Choate. You can find me via email, choate.donald@outlook.com. That's CHOATE.Donald, D-O-N-A-L-D, at outlook.com. And my Twitter handle is @FerrisFox. So you can find me there as well.
Another question, Donald, just came through. Are students learning how to do this in a class here at Walter State?
No, they're not. Well, actually, no, we are. Bob Dixon over in the tech building, he has 3D printers over there, and then the engineering, they learn how to do that. But over here in the science division, no.
Okay, is that something that might be a possibility at some point?
That is something I would absolutely love to see a professor bring into their classroom at some point in time. And some of our professors do encourage the use of the 3D printer for side projects and stuff like that.
I'm just thinking about one of our folks here in the audience was talking about making a heart and lungs. So, I mean, I could see some possibilities of this 3D printing happening right here in this building. So,
in the audience, if any of them are Walter State students or staff, you're welcome to come in here. Natural Science, room 101.
Okay, all right. So we've got, thanks Jeff and Linda for putting up Donald's information there. Please feel free to contact Donald. I'm going to see do another scan of me, and if something comes out, I'm going to tweet at Darlene Smith WS. Oh, what a great idea. Someone just said would love to have a 3D printing club happen.
Now, actually, I'm glad you mentioned that. If you want something 3D printed and I'm not available or you don't have a printer, it's not a big deal. And just for a few bucks, they will send you a completed part. There are even hacker spaces around, and it's not a bad thing. A hacker space is a property that you can go to where you can meet up with creative people, intellectual people, and sit and build and work on whatever you're doing. Knoxville has a hacker space that has 3D printers available that you can go use. It's a membership. You have to pay a yearly membership. Last time I checked, it was $40. But once you pay that, you're welcome to walk into their building and use all of the technology they have laying around there to print and build and create to your heart's desire.
OMG. OMG. All right, so I will be back on Periscope a little bit later with the finished product. Let you see what it looks like. Thank you so much, Donald, for taking your time and letting us learn about all of this. Thanks for attending the 20-Minute Mentor today. We look forward to seeing you next Tuesday morning at 9:30. Have a great day.